Very good afternoon. So, hello everyone. Good afternoon, everyone. Would you please confirm once that you can see me, you can hear me, as well as you can see these slides?
Good afternoon, sir. Yes, we can see you and hear you.
Okay, okay. Thank you so much. Okay. So, let us begin today's session. Okay. So, once again, very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department from IIT Kharagpur, and I'll be taking this live interactive session on the course Computer Vision. This course is taught by Professor Jayant Mukhopadhyay from IIT Kharagpur. And what I'll be doing in this particular session, in the first half of the session, I'll be just solving some of the objective type questions based on the previous week's content in front of you all. And in the second half of the session, I'll be demonstrating some of the concepts, okay, based on the previous week's content as well as what I have just shown you, what I will just show you in the present lecture. Okay, some of the very practical utilities of these concepts I'll try to demonstrate, and the codes I'll try to provide within this particular uh, link which I have already shared in the messages. Okay, for you all. Okay, so first of all, it is a general kind request. Please take a notebook and a pen and try to jot down all the, at least try to jot down the numericals. Okay, what the questions are given and what particular. Okay, just one second. There is some issue, I think. Okay, just one second. The slide has got disconnected. Okay, yes. I'll try to reshare. Just one second. Okay, Once again, I'll try to reshare. Yes. Okay. Yes. So it is a general request that please try to take a notebook and pen. Okay. And try to jot down all the numerical questions. Okay. At least try to jot down whatever things that I'll try to just share. Okay. Uh, the question number and the particular explanation of the question. Okay. And what particular approach I'll try to follow. Please try to jot it down. Okay. Moving forward. The very first question for the today's session is this one. Which of the following is are true for SIFT and SURF? Okay. Computation of scale, space, and histograms of gradient direction are approximated in SURF compared to SIFT. Then integral of images are used in SURF to speed up computation. Next option is small Gaussians used in SIFT are approximated by box filters in SURF. Okay. Then the next option is Haar wavelet responses are used to accumulate the orientation in SIFT and SURF descriptors. Okay. So please try to give your opinions in the chat box. Okay. Regarding the first question, please try to give your opinion. Okay. How do you feel so? Please try to give your opinion. Which, which option will be correct? Then at the end, we will just see, okay, the complete explanation.
A, B, and D are correct set.
Okay. I'll just write it down. A, B, and D. Okay. Good. Yes, indeed. Some of the options were correct, whichever you told. Okay, some were not correct. Correct options are A, B, and C. Okay, D is not correct. We'll just try to see what is the correct explanation. Okay. See, first of all, you have to understand the statement wise. Computation of scale space and histograms of gradient direction are approximated in SURF compared to SIFT. Okay. SIFT will just try to construct scale space using the Gaussian pyramids and it will try to compute accurate gradient histograms as you already know, and SURF will approximate the Gaussian filtering using your box filters and it uses the faster computations. Okay, I will just demonstrate both of these concepts within this particular lecture only, but try to beware with me. Okay, in the previous session also I tried to demonstrate one of the concept which is SIFT practically, but the thing was that it was not that much mathematically driven, it was practically driven. So I'll try to demonstrate both of the concepts. Okay, the mathematics as well as the underlying practical applications within this particular session only. Okay, so SURF will approximate both scale space and orientation as compared to SIFT. So this particular statement will be 100% true. Then you try to see the statement number 2, which is integral of images are used in SURF to speed up computation. Okay. Yes, indeed, SURF uses the integral images to compute the box filters. Okay. The both of the algorithms are just for feature extraction. Okay, feature extraction as well as for key point detection. These particular algorithms are very useful, but the difference is in the underlying mathematics as well as in the underlying approach. Okay, nothing very different or very distinct when it is compared to coding aspects is there. Okay, both of the features are gladly available in OpenCV. Okay, you can just try to use it and try to see yourself that how you are able to match these particular concepts. Okay, I'll also try to do this in front of you. Okay, just try to be with me. Then this particular statement, yes, it is indeed true. Integral of images are used in SURF to speed up the computation. SURF uses the integral images to compute box filters very efficiently. It enables fast convolution. Convolution within rectangular regions. Convolution is a mathematical operator. Okay, this is very important operation in computer vision. Okay, convolution, if you will try to understand, it is a particular operation which will take pixels. Okay, in the size of the convolution matrix. Okay, so convolution, particular mathematical operation is there. Okay, it will try to take the particular it will have a mask matrix. Okay, and it will try to put that particular mask matrix. Okay, it will try to do that convolution operation with the whole entire array of pixels in your image. Okay, when it will achieve particular pattern. Okay, particular pattern means particular similarity. Okay, in any of the region, then it will try to remember it, or it will try to give it as a result. Okay, so suppose a particular matrix of size 256 by 2 in image processing, you must be knowing that the entire thing is fully mathematical. An image consists of pixels. Okay, R, G, and B, red, green, and blue. Okay, all the pixels range from 0 to 255. Okay, in all the three particular matrices, in all the three particular colors are nothing but numbers. Okay, then you try to convert it in black and white for simplification. So it will, the three-dimensional array will be converted to a one-dimensional array that will only have attributes between 0 to 255. And now an image, if it is a 2D image, just for your simplification, image can be in 3D also. For 2D image, okay, if it is of monocolor or just black and white, so entire image will be consisting of pixels in both directions x and y. Okay, so this is the simplest form of an image. And now you try to understand what is convolution. Convolution is nothing but a mathematical masking matrix is there. Okay, suppose it is a 3 by 3 matrix. Okay, and then the entire image is of the size 256 by 256. Okay, it is having values ranging from 0 to 255. Okay, just for your simplification. Now you try to match that particular 3 by 3 matrix with within the entire space consisting of values, okay, between 0 to 255. Okay, in the particular size which is of 3 by 3 size. Okay, then in a particular region, the operation will be continued. Okay, it's a mathematical operation. You try to match the values. Okay, then you will find a certain region of commonality. Okay, certain region of commonality in which you would be able to determine a particular pattern. Okay, so in that particular region, when the pattern is achieved, okay, you just try to say that this particular is the particular object recognition feature. Okay, so this was convolution in brief for you to understand. Okay, already taught in much great detail in our video lectures, but here I was just trying to summarize you. Okay. Yes, surf enables fast convolution within the rectangular regions. Okay, how it is doing so, I try to tell you in brief. Okay, mathematically also I'll try to demonstrate within this particular session only. Okay, now you try to see statement number C was the small Gaussians used in Swift are approximated by box filters in SURF. Okay. Yes, this particular statement is true because Swift uses Gaussian derivatives for scale space construction. Okay. And SURF approximates these Gaussian second order derivatives using box filters just for faster computation. Okay. See, whether it is your signal processing, whether it is your image processing, or whether it is your computer vision, or whether it is your any particular mathematical aspect, in those all those particular domains, filters are very important. Okay, if you are a BTech student, you would be reading electrical engineering, then after that you would be reading mechanical engineering also. Some of the courses will be taught to you. Okay, Within computer science also, some of the courses of electrical engineering would be there, electronics and communication engineering would be there, and within computer science also, you would be taught various numbers of filters. So what are filters and what are the basic aspects? I'll just try to demonstrate. I'll just try to tell you in simple words. Suppose there is a simple computer vision aspect or a simple any demonstrative aspect of signal. Okay, so in signal processing, some noises would be there. Okay, noise means nothing but unwanted part of the signal. Okay, unwanted part of the signal, or if you want to measure a particular signal, suppose a signal you want to measure which is of the form sin x. Okay, then some of the frequencies you will be getting as interferences which would be very different from the inherent nature of the signal which you want to measure. Okay, so those particular noises you just have to eliminate. For eliminating those particular noises and for completing your analysis, what you would be doing, you would be putting some of the filters. Okay, so some of the filters, okay, which are used in that particular domain are RF filters, CF filters. Okay, these all are filters. Okay, for attenuating or for cutting those particular noises. Okay, so similar to those particular concepts, these are the concepts in image processing. Okay, two particular algorithms are there. SIFT is there, SURF is there. SURF is basically trying to cut those particular noises for faster convergence. Faster convergence means you generally want to achieve the results within the shortest possible time. Okay, within the shortest possible time. First thing is this. Another thing is computational complexity, time complexity in computer science is very, very important. Both of these should be should be as less as possible, and the fastest convergence should be there. Please remember, in order to evaluate the performance of any algorithm or code whichever you are writing, either by using an AI tool or by using any of your by using your own knowledge, or you are taking from any other source, the principal aspects which we are having to measure or evaluate the performance of any algorithm are very, very simple. These are three. Okay, time complexity, space complexity, okay, space and time complexity, computational complexity, all the complexities you try to measure. Okay, as well as another aspect is convergence. Convergence should be as fast as possible within limited memory usage. Okay, so this particular are the full aspects. Okay, and here you try to see that we are using box filter for fastest convergence. This particular is the statement aspect of this particular statement. Okay, then you try to see statement number D. Okay, Haar wavelet responses are used to accumulate the orientation in shift and serve descriptors. Okay, this statement is false. Why? Because Haar wavelet responses are only used in surf, they are not used in shift. Okay, because shift will try to compute the gradient magnitudes and orientations directly using your Gaussian smooth images. Okay, then this statement is only partially correct and it is not a fully true for both of the aspects. Okay, so the correct options would be A, B, and C. Okay, and the concepts I tried to say in brief to you all. Okay, now you try to see scale space construction. Okay, Shift, it particularly builds a Gaussian scale space by convolving the image with Gaussians at multiple sigma values. At each octave, you downscale by half, then you apply Gaussian blurs. Okay, sigma, k square sigma. Then you try to create a stack of progressively blurrier images. Okay, the difference of Gaussians between successive blur images approximates the Laplacian of Gaussian and extrema in DOG across a scale, and you try to give the candidate key points. Already demonstrated much in great detail in my previous session also. Okay, then you try to see the surf, which is speeded up for robustness. Okay, first of all, you try to create an idea, you try to generate an idea, then you try to increase the robustness or increase the efficiency of that particular algorithm. Okay. So it also wants a scale invariance, okay, faster convergence, but instead of true Gaussian, it uses the box filters, which are nothing but the rectangular kernels, okay, of increasing size. Then it because of the integral image, the sum of the over entire rectangle can be computed constant time regardless of the filter size, and you try to simulate a larger Gaussian at scale sigma, then surf simply picks is a simple box filter which is of somewhat larger size, okay, much faster, okay, as compared to your shift, okay. So aspects as well as both of the things, okay, as well as the computational complexity, it is ks square in case of shift, okay, very very important for you to understand. Just a second, yeah, this particular thing and integral images big O notation 1, okay. So both of these aspects are very very important, okay, for you to understand. Then you try to see the orientation assignment, okay. After finding a key point at a particular scale and orientation, okay, both the methods assign it a canonical orientation. So the descriptor is rotation invariant, okay. In case of your shift, okay, in case particularly of your shift, I told you that Gaussian filters are used, okay, within a certain circular neighborhood around a key point. You try to compute the gradient at each pixel, okay. The gradient is demonstrated like this: m xy, okay, delta x means in x direction I, okay, plus delta y in I, and you compute the squares of both and under root, okay, using the Manhattan formula, okay. Then you try to form an 8 or 36 bin histogram using these theta values weighted by magnitude and by Gaussian window centered at the key point, okay. Then the peak of this particular orientation histogram will be your key point uh, assigned orientation, okay. Then surf, okay, instead of pixel by pixel gradient, surf uses R wavelet responses, okay, in x and y directions over a particular circular region, and these R wavelet responses can be computed very quickly, okay, via the integral images, and sum of all responses within a within sliding angular sector, and pick up the sector with the largest sum response, okay. This one is regarding your surf. Then orientation, okay, entire in the entire subspace, how we will apply this particular shift, okay. Rotate the coordinate frame to align with the key points orientation, then divide the neighborhood into subregions. For each subregion you try to apply those particular formula, gradient formula that I showed you earlier. Then you try to concatenate these in the various directions, okay. This one was your for your shift. For your surf, you need to rotate the patch to the key points orientation, divide into 4 by 4 subregion, and for each subregion you need to have a four-dimensional vector, okay. Then you try to concatenate, then you try to normalize also, okay. These all aspects have been given here, and final length as well as all the aspects are given. Then what are the summary? In summary, scale space in shift it is true Gaussian. In surf it is box filter via integral images. In case in your gradient versus Haar filters, okay, shift uses exact gradients, surf uses Haar wavelet responses, okay, approximated histogram. Then in case your speed versus precision, surf approximations gives a 3 to 5 times speed up over shift, okay. So the decision choice as a design engineer you sometimes have to make, and all the aspects, different aspects I have given you, whether it is integral images, whether it is box filter, whether it is wavelet response, you just have to see, okay. Moving forward to the next question, which of the following is a true, okay. If you are having any doubt at any point of time, then please feel free to ask. Okay, if no doubt is there, then I'll try to move forward. Question number two. Which of the following is are true? Okay. Ransack is best suited for fitting outliers. Half transform is best suited for line fitting in presence of many lines. Then Kullback-Leibler divergence is best suited to find the optimal line parameters when points belonging to the line are given. Okay. Then the average case time complexity of NN search using KD tree is big O notation log n plus 2 raised to power d, where d is the dimension of the feature space. Okay. This is a question posed in front of you all. Please try to solve. Please give the response. Not much calculation is required. Okay. You can be correct. You cannot be correct. Okay. Then we'll try to see which is the correct option. Okay. Please try to respond. Okay. At least give your opinion. All the concepts were taught in the previous session, in the previous week. Okay. It's also MSQ, and you can expect number of these questions in the final examination in which you all would be appearing. Okay. Number of questions would be like this. They would be MCQ, they would be MSQ, some of the descriptive also. Okay. Mixed pattern is generally followed. Okay. Try to respond. Take 2 minutes time. If no response is there, then I'll try to solve. I'll try to demonstrate. Okay. Yes. Indeed, the correct solution would be A, B, and D. Okay. For this particular question also, the correct options are same as compared to question number one. Okay. It is A, B, and D, and this particular option is not correct. Okay. Ransack is best suited for fitting outliers. Okay. Fitting outliers. If you, I try to s- tell you in simple words, outliers are nothing but the same thing which are there in your linear regression or any other regression. Okay. If you try to fit particular line through these particular points, okay, x and y points, okay, then these all which are not fitting the line, okay, these all are outliers. Okay. So for any of the distribution, okay, for any of the distribution, whichever it is there, okay, some outliers would be present when you try to model any of the equation, any of the images. Okay, if you try to model, then you would certainly have some of the outliers. Okay, so Ransack is best suited for fitting outlier. This statement is true because what Ransack does, random sample consensus. Okay, it repeatedly samples the minimal subsets of your data and it tries to fit a candidate model, okay, to each subset, and then it counts how many points agree within that particular model. Okay, why it is particularly able to handle the outliers? Outliers, as I already told you, points that don't fit the model, they are simply ignored in the consensus set. They are the outliers. Even if a large fraction of your data are outliers, as long as there is a sufficient number of inliners, then SEC will be having high probability. It finds the model by sampling inlier subsets. Okay. So what the particular model is trying to do, it is just trying to uh, if in your data set large fraction of outliers are there, okay, the inliers, it will try to just focus on the inliers. Inliers are nothing but those particular points which are following the trend. Okay, those particular points are your inliners, okay, which fall in the trending direction. Okay, so it will try to focus just on those particular points which are the inliners. Okay, we'll try to ignore the outliners or outliers. Okay, so for fitting planes, for fundamental matrices, for your homographies we have just seen in till week number 5. Till previous week we were seeing the homography in much detail. Okay, as well as all the aspects in the computer vision we just have seen. Stereogeometry also we have seen. So in those particular aspects this is very important. Okay, next is half transform is best suited for line fitting in presence of many lines. Yes, it is true. Because what half transform does, it maps each edge in image space into curves. Okay. What half transform does, it maps each edge in image space into curves. Okay. In a particular space, okay, peaks in that parameter space correspond to lines in the image. Okay, because each line produces its own accumulator peak, the half transform can detect multiple lines simultaneously even when they intersect or overlap without having to segment or cluster first. Okay, use cases are for your road lanes, for your building edges. In your scene, if a scene is given to you, then you can use the half transform. And if you are regular in this particular in these particular sessions, then I have demonstrated the practical application which I have applied in my own research. Okay, for detecting the for detecting the crop rows and for guiding the autonomous vehicle within the lane. Okay, that particular demonstration I already have made in front of you. Okay, next is part number C. Okay, Kullback-Leibler divergence is best suited to find the optimal line parameters when points belonging to a line are given. Okay, this is statement is false because scale divergence means the distance, which is uh, the KL divergence. It measures the distance between two probability distributions. Okay, then it is not for line fitting. Line fitting is typically posed as minimizing the geometric error. Okay, or the algebraic error. The KL divergence isn't naturally applied to point to line residuals. Okay. So KL divergence isn't applied to point to line residuals unless you are trying to impose some probabilistic generative model on residuals. Okay. Then you need more directly maximize a likelihood or minimize a quadratic loss. Okay. Best alternatives are M estimators, RANSAC, or ordinarily OLS, ordinary least square regression. Okay, total least squares, these all you can apply. Then part number D was the average case time complexity of NN search using a KD tree is big O notation log n plus 2 raised to power D, where D is the dimensional feature. Okay, D is feature dimension. In your NN search in KD trees, okay, the you traverse one part down, then the tree cost would be big O notation log n, but you may need you to also backtrack it, okay, to explore other branches. Okay, in your D dimension, the worst case which you would be ending up would be having the dimensionality of 2 raised to power D. So fitting together the combined complexity would be big O notation log n plus 2 raised to power D. Okay. This D will continue to degrade, and this is also this will be known as the curse of dimensionality, and this is the main reason, primary reason why there is a particular problem, which is the traveling salesman problem, that is known to have the largest complexity. Okay, one of the problems which is known to have the largest complexity. A lot of solutions have been proposed to it, but till now, till the date also, a lot of improvements are also required. Okay, so that is the case. Curse of dimensionality is faced here also, as well as in one another problem, which is traveling salesman problem, one of the hardest problems in computer science. Okay, next is in great detail. If I'll try to tell you, RANSAC is random sample consensus. Okay, trying to fit a model, line, plane, homography, or fundamental matrix to data containing a significant fraction of outliers. Okay, core idea is for random sampling, then you try to model the hypothesis and try to build the consensus and try to give a best fit model. Algorithm steps are also given. Okay, data set D is there, model size M is there, then you try to loop between I to K. Okay, randomly select M points from D, then try to estimate the model parameters theta I, then compute all the residuals, define the inliners, then try to compute the best model. Okay, complexity and parameters for iterations K chosen to bound the failure probability P. K is approximately log 1 minus P over log of 1 minus epsilon raised to power M, where epsilon is the outlier fraction, and per iteration cost of this particular algorithm would be between big O notation M to big O notation N. Okay. Then strength and weakness, yeah, it is very robust to large outliers ratios. It is simple to implement, extend. It is non-deterministic. Tuning T and K can be tricky if outlier rate is unknown. And for your half transform, okay, it is a simple algorithm, okay, which tries to perform the edge detection, edge point. Okay, each edge point x comma y in image space votes for all lines that could pass through it. For your parameterization, a 2D line can be represented in polar coordinates as rho equal to x cos theta plus y sin theta. Okay, where theta belongs to uh, open interval 0 to 180 degree and rho belongs to R. Then you try to perform the accumulator. Okay, then you try to detect. Okay, algorithm steps are very simple: edge detection, then accumulator initialization, then you try to vote, then you try to find the peak. Okay, then line extraction. Okay, the complexity is big O notation P cross T. Okay, P is the edge pixels and T is the distinct direction theta. In my research project, I only applied half transform in one direction, that is in the forward direction. Okay, but in the complex problems, we need to apply the concept of half transform in 2 or 3 directions. Okay, even in 2 3 directions, and nowadays when it comes to 3D LiDAR data, they are applying in 360 direction, in 360 particular thetas. Okay, so this technology is coming and try to catch up with it. That is my sincere advice. Okay, then memory size is depends on the size of accumulator, which is big O notation R cross T. Then strength or weakness are it is able to detect multiple lines simultaneously. It is able to handle intersections and partial occlusions. Okay, high memory and compute if fine discretization is needed, then choice of thresholds and bin sizes affects the accuracy. Then your Kullback-Leibler divergence goal is to measure how one probability distribution forms a reference distribution P. In case of your discrete distributions over domain chi, it is defined by this particular expression, and your asymmetry is there, then zero minimum is there, information loss is there. Model comparison always you can perform by fitting the lines. Okay, different mathematical aspects are there. Okay, regarding your Kullback-Leibler uh, divergence. Okay, it is not fitting the line because we need to minimize the residuals. Okay, Because larger we will try to minimize the residuals, the higher the accuracy of the model would be there. Okay. Then your nearest neighbor search in your KD tree. Okay, goal is to form a set of endpoints in the relation r is to power d. Pre-process to the answer which point is closest to the query q. Okay. Now you try to perform the analysis. Then in case of your KD tree, what is KD tree? What we are referring with this particular statement, a binary tree that will recursively split, okay, along one coordinate axis at each level, cycling through different dimensions, okay. Then your each node will be split into left and right direction. In average case search algorithm, it will try to traverse down from root, then leaf it is reached, then it will try to compute the distance, and it will also try to backtrack and return to the nearest point which is found. Okay. Time complexity is big O notation log n. Okay. And in case of your backtracking, in d dimensions, the number of additional branches examined grows roughly like 2 raised to power d. Okay. So average case is the complexity is big O notation log n plus 2 raised to power d. Okay. And worst case, it would be degrading to big O notation n if data are adversarial or d is very, very large. Okay. Yes, there is curse of dimensionality. Okay, case in this particular case, there is curse of dimensionality, as you can see. Okay, as well as in the particular problem, I try to tell you traveling salesman problem. There is curse of dimensionality, and all the models, all the methods. Okay, ransack, half transform, KL divergence, KD tree, and in search the query complexity I have demonstrated. I have written in the last column, as well as the robustness to outliers, the multiple models it is trying to accumulate at once or not, what is the parameter estimation, what is query complexity, it has been mentioned here. Okay. And as a design engineer, it is our responsibility that which tool we just have to pick it up, okay, and try to involve in our own use case. Okay. Then question number 3, consider a set of parametric equations x equal to t cube plus 2t square, okay, and y equal to t square plus t, then representing a 2D curve, then you have to compute a tangent vector at t equal to 2. Okay, very simple question it is. Okay, in class 12th also you must have just solved this particular question. Okay, so please try to solve, try to tell me the answer. Takes 5 solid minutes. Okay, very, very important for you to understand this. Please note it down, and in the chat box please try to give the opinion. This is a very simple question, and if it comes in the examination, please don't leave it. Okay, I'll just give you full 5 solid minutes, okay, for solving this particular question.
Sir, answer is C. Excuse me, sir, are you there?
Yes. Okay, C. Okay. Question number 9, I didn't ask. Very sorry for that. Next. Question number 9, answer. Okay, question number 3. I'm thinking it is question number 3. Answer B. B, two people B, then. Okay, B, then C, then B. B, then B, okay. Then C and C. Okay, B and C, okay. Okay, okay. I am very happy that at least you try to solve. Okay, this is for you guys only. Yeah. Consider a set of parametric equations x equal to t cube plus 2t square, y equal to t square plus t. It represents a 2D curve. Then you have to compute the tangent vector at t equal to 2. You have to perform the derivation and then you have to see that it would be option number C, it won't be option number B. Okay. To find the tangent vector, first of all, you have to differentiate that particular expression. Okay. The equation has been given in parametric coordinate. Okay. So x has been given to you as t cube plus 2t square, y is has been given to you as t square plus t. Okay. So differentiate x with respect to t, you would be getting 3t square plus 4t, and differentiating y with respect to t, you would be getting 2t plus 1. Okay. Now at t equal to 2, okay, at t equal to 2, if you try to put t as 2 in this particular expression, then it is 3 into 2 square plus 4 into 2. It would be 12 plus 8, that is 20, and y dot at the value 2. Okay, because t has been mentioned as 2. Okay, that is why we are putting t as 2. It would be 2 into 2 plus 1, that is 4 plus 1 equal to 5. Okay, that would be option number C. Okay, indeed, whomsoever have answered C, they are correct. Okay, and B is not correct. Very sorry for that. Please try to be a little bit more careful in the examination. We shall move forward to the next question. This is also a very simple question. Consider the following matrix representing four sample data points. Okay, four sample data points: 1 comma 2, 2 comma 1, 3 comma 2, 2 comma 3. Okay, as a simple matrix capital X equal to 1 2 2 1 3 2 2 3, then compute the covariance matrix using the data points from X. Okay, please try to note down this particular concept. Take 2-3 minutes time, try to solve. Okay, because when you will be solving, then only you would be committing some mistakes. Then after that, you will try to see the solution. After that, only you will learn. Okay. Okay, I hope that you have noted this particular question. I just try to tell you in brief. Correct option would be option number B. Yeah, B is correct answer. Definitely you are correct. B is correct option. Okay, because full step-by-step computation, if you will try to see the data matrix X has been given to you. Okay, each row is having one sample xi, then you try to compute the mean. Okay, mean would be nothing but the sum of all values. Okay, x's which are 1 2 3 2. Okay, 1 2 3 2, sum of all these thing is 2 1 3 3 3 6, 6 plus 2 is 8, 8 over 4 values, 8 by 4 is 2. Okay, that is your mean in x direction. Mu x, mu y, if you will try to compute, it is 2 1 2 3. Okay, 2 1 2 3 are the values which are given in y direction. Okay, so mu y, if you will try to compute, then 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 by 4 is 2. Okay, then you have to compute the form the zero mean data matrix, means subtracting all the particular values with mean. Okay, so if you will try to subtract and form it in elemental form. Okay, form this in elemental format like this, because mean is 2, so I'll be just deducting all the values with a particular number which is 2. Okay, with this number 2, if I'll try to deduce, then it would be this particular matrix. Okay, minus 1 0 1 0 0 minus 1 0 1. Okay, then you try to compute the covariance matrix. Okay, using the population formula. Okay, dividing n s4. Okay, mu equal to 1 upon a n x transform zm x zm. Okay, so 1 upon 4 by all this particular elements. Okay, then you will get the top left entry as 2, top right entry as 0, and this is the simple calculation. Then you will get all the values as 1 upon 4 2002, that is 0 0.5 0 0 0.5. Okay, that is same as I think option number B. Okay, so this one would be true. Okay, final answer is option number B, and this particular well matrix. Okay, if any doubt is there, then after the class is over, please try to see the PDF. Okay, in the PDF itself, the entire thing has been solved. Okay, you will get a lot of aspects here. Okay, just 1 second. Yeah, yeah. Question number 5. Okay, The top left corner of the matrix is considered as 1 comma 1 indices increment for x and y along horizontal right and vertical downward directions respectively. Then consider a 3 by 3 matrix A equal to 0.3, 0.1, 0.6, then 0.5, 0.2, 0.3, 0.1, 0.3, 0.4. Then compute the magnitude and orientation in degrees using first order first difference operator at the center pixel respectively. Okay, just have to compute this particular thing. Please note down at least the matrix, at least the values. Okay, whatever thing that has been asked here, please try to note it down. Okay, then we will see. Okay, okay, B is the correct answer. Good. For this one also, B is the correct answer. Please solve also, even if you know the answer. Okay, solve so that in the examination you won't be facing any particular problem. Okay, try to solve also, even if you know answer, then also you try to solve. Even if you don't know the answer, then also you need to solve. Okay.
Sorry to interrupting you, sir.
Yes, yes.
Yesterday we had session with Ayan Pal.
Oh, okay, okay,
That's
okay.
it.
Yes.
So, sir
Okay.
also say explained same problem. So I am telling answers very quickly.
Okay, okay,
Yeah.
okay, okay. No problem is there. Okay.
Okay.
For this particular course, three particular sessions are there, and they all would be teaching you these objective questions along with the concepts and
Yes,
some of
sir.
the
Yes, sir.
proofs.
Yes,
Okay.
sir.
Okay. And I appreciate your honesty. Thank you so much for that. Yes, indeed, the correct option would be B. Okay. The matrix along with the coordinates has been given to you. Okay. Point 0.3. Okay. Yes, point 0.3, point 0.1, point 0.6, point 0.5, point 0.2, point 0.3, point 0.4, point 0.3, point 0.4. Okay. Then you try to compute the center pixel, which is 2 comma 2. Okay, which is point 0.2. Okay. Then you try to apply the central difference formula, okay, in the horizontal component as well as in the vertical component. Okay. Then you try to compute the gradient magnitude, okay, in x and y direction. Use the Manhattan rule. It would be 0.1414. Then the orientation would be tan inverse gy over gx, okay, which is tan inverse negative of 0.2 minus 0.2. Tan inverse minus 1 is minus 45 degree. Final result is magnitude is 0.1414 and orientation is minus 45 degree. Okay, so it is option number B. This is correct. Okay, rest all the mathematical aspects in brief has also been given here. Okay, yeah. Goal is to compute the gradient vector gx comma gy at particular pixel xi comma yi. Okay, I think the screen has got detached once again. Just let me reshare. Okay, yeah, just 1 second. Just 1 second. Okay, there is a problem with screen sharing. Just try to sort it down. Then we will see. Question number 6. Okay, yeah, we are back in business. Yes, yes. Goal is to compute the gradient vector. Okay, gx comma gy. Okay, at a pixel xi comma y representing the rate and direction of change in the intensity, magnitude of this vector, orientation of this vector. Okay, magnitude will give us the idea how strong the change in intensity is, and the orientation will give the direction in which the change points to. Okay, gradient is del f over del x, del f over del y, which is in written in short as gx comma gy, where x is the horizontal position, y is the vertical position. Okay, then you try to see first order central difference to estimate these partial derivatives from a discrete image. We will use the central difference approximation. Okay, gx. Okay, f of xi plus 1 yi, okay, minus f of xi minus 1, okay, yi. In vertical direction it would be f of xi yi plus 1 minus f of xi yi minus 1, and magnitude of gradient would be nothing but under root gx square plus gy square, half of that. Okay, we are dividing it by 2 because the central difference will spans at a distance of 2 pixels. Okay, so that the gradient should be scaled accordingly. Okay, this is the reason. Okay, moving forward, orientation. Okay, angle of gradient. To determine the direction of change, we have to compute the angle, which is theta equal to tan inverse gy over gx, which is measured in degree or radians. Visual intuition you can see here, as well as the calculation we already have performed. Okay, applications are there in edge detection in case of a feature detector. Okay, in image enhancement, even in your motion estimation. Okay, motion estimation and path tracking, key point detection, these are very important aspects which are nowadays gaining a lot of insights. Okay, in practical applications regarding computer vision. Okay, so this is the summary: gx, gy, then magnitude, orientation, everything we just have seen. Okay, then coming to the next question, which is question number 6. Okay, if an octave in shift operator has 10 images, then the scale factor by which each image in octave differs from the next images. Okay, please try to note this particular question. Okay, then we'll just see what is the solution and how we can solve this particular question. Okay, okay, the correct option would be A only. Okay, we'll just try to see. In case of your shift, okay, the key point scales within each octave are spaced so that the sigma values, okay, double over the entire octave, and the intermediate levels are equally spaced in your log scale. Okay, if an octave contains s plus 1 Gaussian blurred images, then s will be s is equal to multiplicative steps between the first and the last. Okay, so k is 2 raised to power 1 by s. In your problem, octave is having 10 images, so s plus 1, okay, will be equal to 10. So s is equal to 9. K is 2 raised to power 1 upon s, that is 2 raised to power 1 upon 9. Okay, and if you will try to compute this particular thing, okay, 2 raised to power 1 by 9, it is approximately 1.0800. Okay, so it is in the option A. Okay, option A would be correct in relation to this particular question. Okay, if we try to see it in detail, how shift will build up the scale space and why step size successive between successive blur levels in an octave is k equal to 2 raised to power 1 upon s. For your Gaussian scale space in Swift, the Swift needs to detect features that are invariant to scale. To do that, it creates a pyramid of images blurred by Gaussians of increasing standard deviation sigma. Okay, an octave is the set of images where sigma will double from its first to its last image within one octave. Okay, Shift produces a series of blurred images. Usually, how you are seeing this particular one octave, okay, it might look like this particular format and manner in which level 0, level 1, and level S. Okay, all the levels have been shown here. Okay, then doubling the scale over an octave, what it means in your signal processing, octave means doubling of frequency. Okay, in the scale space, we invert that notion and call it an octave the doubling of blur width. Okay, sigma last equal to 2 times sigma first. It will ensure that when you move from the start of octave O to the start of octave O plus 1, you have just effectively downsampled by 2. And then you reset your blur to the same starting sigma, then spacing the intermediate levels within that doubling of sigma. You want S uniformative multiplicative steps, okay, so that feature detection is roughly equally sensitive within the entire whole range of the octave. Okay, so that is why the labels have been defined like this, and we actually derive the formula k equal to 2 raised to power 1 upon s. Okay, then relating images per octave, okay, to interval s that has been given here, and we just try to compute. And if you will try to compute for all the levels within that particular octave, that calculation has been shown here. Okay, this is the regarding this particular question. It the practical aspects are for uniform coverage, for efficient sampling of the points, as well as for consistent doubling. Okay, so these are the principal aspects. Okay, that is why this particular octave has been defined like this. Okay, next, moving forward, question number 7, given two features, each of size 7 as f has been given, function values has been given, g has been given with a particular functional value. Then you have to compute the L1 norm as well as the L2 norm between two functions f and g. Okay, try to compute, at least note, jot down your function f, your function g, then we will try to solve L1 norm and L2 norm. Okay, okay. So L1 norm is the Manhattan norm, which is defined as summation of the values xi, and L2 norm is the Euclidean norm, which is defined as the values sum of all the squares, and at the end you have to take the under root. Okay. So in this particular case, two particular vectors have been given f and g. So L1 norm will be nothing but differences of the values, and at the end you have to take the mod. Okay, after summing all the values, take individual mods, then you have to sum the values. Okay, in L2 case, you have to square all these values, take the under root after summing the values. Okay, so f has been given here, g has been given here, d. Okay, in this format manner, if you try to compute the difference of the values, you can do this like in a tabular format. Okay, Then f minus g, okay, the modulus of that, okay, di differences we have calculated, mods we have taken, okay. Then L1 norm is nothing but the sum of all these values, which will be 10, okay. And then di we have calculated, one another term will be calculated, which is di square, okay. So sum of squares of these particular values, then after that you have to take under root also, that would be 5.29. So in this form and manner, L1 norm and L2 norm you can compute in the examination. Okay. Then L1 is 10, L2 is 5.29. So 10 and 5.29 are the correct options. Option number C. Then question number 8, which of the following is a true for edge and corner detection? Corner will have low maximal and minimal curvatures. Corner will have high maximal and minimal curvatures. Edge will have low maximal curvature but very high minimal curvature. Edge will have high maximal curvature but very low minimal curvature. Which option do you feel is correct? Please try to comment it down. Okay. Okay. In this case also it's an MSQ. Okay. Multiple select question. Correct options are B and D. Okay. Why B? Why D? We'll just try to see for your image intensity surfaces, two particular principal curvatures, K1 and K2, you can see, which is corner and edge. Okay. Surface will bend strongly in both orthogonal direction in case of your corner. In case of your edge, okay, the surface bends strongly along only one direction. It is flat along the edge itself. One curvature is large, other one is nearly zero. So the two statements are B. Corner will have high maximal and high minimal curvatures, and D. An edge will have high maximal curvature but very low minimal curvature. Okay. Why? If you try to model it using the Hessian, okay, for smooth intensity I x comma y, the second derivative matrix, which is the Hessian matrix, has eigenvalues k1 and k2. They will measure how sharply the I bends along the principal axes. Okay. So edge will have one strong bend and the corner will have two strong bends. Okay. So these two particular matrices we try to just compute, and then we try to say that whether it is a edge or it is a corner. Okay. In your image analysis, we often think that the intensity surface I x comma y is a 3D terrain, okay, where the height is gray level. Any point on this surface, the way it bends in different direction tells us whether we are on a flat region or in an edge, or in case we are on a corner. Okay. Hessian matrix is defined like this. Eigenvalues are defined like k1 and k2. Then you solve the determinant h minus ki equal to 0. Two real roots you will have k1 and k2, which are the principal curves. K1 will have the maximum bending, k2 will have the minimum bending. And then you try to interpret the curvatures. Okay. K, in case of your edge, okay, k1 will be large, k2 will be 0. In case of your corner, it would be both the k1 and k2 would be large. Okay. So if you know the basic aspects of coding, you can yourself write the code using this particular concept that try to take an RGB image or a black and white image and try to compute how many number of corners and how many number of edges you are able to find in case of a matrix, in case of a given image. Okay. This is very important in your edge detection in case of your Canny edge detection, in case of your Hessian based edge detection, and in case of your corner detection using the Harris or Hessian determinant. These particular aspects are very important. Okay. High curvature, it will mean that intensity surface will bend sharply. Low curvature means little or no bend, means that is absolutely flat. Okay. Visual illustration also you can see in case of your peak or saddle. Okay. High K1, high K2. Okay. These particular analysis you can perform yourself, and if you know little bit aspects of coding, you must be knowing because you are a computer science student, then you just try to prepare a code for this also. Okay. Then question number 9, given two features of size f, size 5s, f and g, then compute the L1 norm between f and g. Same question, nothing new. L1 norm already I have taught you how to calculate. F and g has been given to you. You try to compute the difference di f minus g. Then you try to take the modulus and you try to take the sum, and it is coming 8. Okay, and if it is a numeric question, please try to understand this, that you will get full marks only if you will write the answer as 8. Okay, or 8.0. You won't be getting full marks in case you will write it down as something else. Okay, since it is a numerical question, please write it down very correctly. Okay. Then question number 10, find the eigenvalues of the matrix and 1 2 2 comma 2 1. Okay, very simple question, this particular one. Okay, you already know from your BTech first year engineering mathematics 1 or 2 that for a particular matrix, okay, for calculating the eigenvalues, we have to use the characteristic equation, which is defined by determinant of A minus lambda I equal to 0. So A as a matrix has been given to me. I'll try to substitute uh, I'll try to subtract the matrix lambda I. Lambda I means particular identity matrix of the same order would be there. Okay. A has been given to you as 1, 2, 2, 1 minus lambda, and identity matrix would be of the same order equal to 0. Okay. So it is 1 minus lambda 2, 2, okay, 2, then 1 minus lambda determinant equal to 0. Okay. So this is has been mentioned here. Okay. Sorry for my bad handwriting. This is because of the stylus. Okay. So determinant of this particular thing should be equal to 0. If I try to build, okay, I'll get this particular equation 1 minus lambda whole square minus 2 into 2 equal to 0. Okay. So 1 minus lambda square minus 4 equal to 0. So you will get the values of lambda as minus 1 comma 3. Okay, so 3 comma minus 1 is option number C. Let me save this for you all. Okay, 3 comma minus 1. Okay, 3 comma minus 1 is option number C. Okay, yes. Yeah. Yes, so my dear students, this marks the end of the 10 questions which I wanted to discuss with you. Now, in the remaining part of this session, I have prepared some of the collab notebooks. Okay, I'll try to demonstrate in front of you all that how the practical aspects of these particular concepts are built. Okay. let me just reshare my second screen. Okay. Yes. This is off. Yeah. Let me just reshare my second screen. Okay. Yes. Just 1 second. Yeah. Okay. So, yeah, what number is it? Yeah. So, in the previous session, a particular query was from your side. Okay. That, sir, what is Lois ratio test in SIFT? Okay. So this is very, very important for you to understand that what is Lois ratio test and how this particular test is applied. So for demonstrating that, I have prepared a separate Google Colab notebook. And previously, told you, I taught you how you can use this particular tool which is Google Colab, okay, in order to run all your Python codes, okay. By default, a Python version would be installed inside this particular Google Colab notebook, and you have to be very, very familiar with this particular platform. Okay, I'll be providing you this particular notebook. No need to worry about that, but you just have to run for your own research for building your concepts and how you can do this. You just have to open Google. Okay, inside it, you have to write Colab. That after that you have to go to Google Colab. Okay, then you have to upload a particular notebook which I will be sharing with you. Use the browse button, and then inside your uh, using the browse button, try to locate, okay, where you have just downloaded my this notebook. Okay, so Lois ratio test demonstration is there in this particular notebook. Okay, when you are when matching feature descriptors between two images, in case of your stereo vision or in case of your computer vision, there are multiple potential matches within each key point. Okay, first of all, we have to perform the key point detection. After the key point detection, we will be having multiple matches. Okay, so to filter out whatever are the ambiguous or the doubtful matches, we use a particular indicator, which is the ratio test, Lewis ratio test, which is nothing but here it is mentioned d1 over d2, d1 divided by d2 less than tau. Okay, where d1 is the closest match, okay, d2 is the second closest match, and a particular threshold here I have provided between zero point 0.7 to zero point 0.8. What this particular Lois ratio test will perform, it is not Lewis, it is Lois. I'll just correct it here. Just 1 second. Mistake is there from my side. I'll just correct it here. Okay. Yeah. So this is here it is written d1 over d2 less than tau, and d1 and d2 I already told you what we are trying to do here. We are just trying to reduce the number of features. Okay, reduce the number of features in your key point detection. Okay, because after key point detection, if you will try to match each and every feature with one another, then a lot of possibilities would be there. Then in all of those possibilities, the important ones which will yield some better results would be lost. Whether it is your stereo vision, whether it is your computer vision, whether it is your object detection, whether it is your edge detection. So this tau that has been approximated as zero point 0.7 to zero point 0.8, if you want your key points or your feature descriptors to be less, then you need to increase this particular threshold. Okay. Increasing this particular threshold to zero point 0.9 will further reduce the number of the closest matches. Okay. Then similarly, you can make a plot also. The plot between tau and the number of feature descriptors. This is a particular exercise which you can do that will immediately give you the idea that how this particular this particular aspects are being dealt. Okay. So steps which you have to perform here is you have to load one or two images, then you have to detect the shift features, then you have to match the descriptors using your brute force technique, then you have to apply the Lewis ratio test, and then you have to visualize the matches. This is the particular aspects. Okay. So results you will get that what are the nearest matches, what are the good matches that you will be able to perform only after your Lewis ratio test has been fully performed. Okay. Yes, these aspects you can do either, otherwise you can also prepare an interactive slider here. Okay, this particular step or task you can perform within this particular notebook also. Okay, to in order to facilitate that how your key points or your feature estimation is changing with respect to your tau. Okay. So here, if you will try to see in this particular notebook, I am performing Lewis ratio test. Okay, this particular thing I am performing in your Google Colab notebook. Okay, first of all, I am installing the requisite libraries here. Then I am importing some of the libraries CV2, NumPy. Okay, then matplotlib. Okay, URL request. Okay, then you try to see that I have downloaded some of the sample images, two particular sample images which I was talking in the previous in your just preceding to toward this section. Okay, there I was talking about two images. So these two images directly from open source dataset I have picked up. Okay, these two particular images, this particular image and this particular images I have picked up for your for my demonstration. These both are open source images. Okay, so nothing new is there. Okay, this already we have done in our previous session also. Then we are loading the images img1, img2. Okay, then we are initializing our shift detector, which is already a function in your OpenCV library. Okay, then you are performing the key point detection. Okay, as well as the descriptors we have just tried to make here. Okay, these functions we are trying to call. Then you are performing the brute force matcher. Okay, along with your k nearest neighbor detection. Okay, in this particular step, the codes are important, the syntaxes are important, because if you will make some of the mistakes, then you won't be able to get the requisite outputs. But my sincere advice to you is that before applying any of your particular uh, particular function, please always beware of the mathematics which is there behind that particular function also. Okay, because directly whatever steps I have just demonstrated in the preceding my markdown, okay, that I have applied here, because in Python these are pre-built functions. Okay, so nothing new I have done here, no mathematical aspects are there. But if you are but it is a primary request for you all guys, since you are a computer science student. Okay, you must be aware what are the principal aspects and what are the previous denominations. Okay, because of which my this entire thing is happening, my this particular feature I am able to recognize like this. Okay, so nowadays the thing is that TensorFlow library is there, other libraries are there, nobody is defining a neural network from scratch. They are taking the pre-built functions like I have done. So similar things are being done uh, for the facilitation, okay, of people. The pre-built functions are already there, half transform for each and everything, pre-built functions would be there. But if you are knowing the mathematical aspects behind those pre-built functions, then only you would be able to mathematically manipulate those particular functions and generate some new results, as well as you would be able to define new functions also. So these two particular aspects would you would be able to do if and only if you would be knowing that what are the existential functions. What are the existential functions? What functions already exist within our own context? Okay. Yes. Then only you would be able to define some of the new functions. Okay. As well as you would be able to mathematically manipulate some of the existing functions also. Okay. So my sincere advice to you is that please try to thoroughly revisit all the functions, all the descriptors, all the indicators which are there inside a particular notebook. Okay. And I'll be sharing all these notebooks with you all. Okay. And if any doubt is there in any descriptor, feel free to ask me, even in this session or in the next session. Okay. So after this, we are applying the exact step of Lewis ratio test here. Okay. We are making a particular array good matches. Okay, then ratio threshold I have applied as 0.75. Then using the for loop, I have compared these particular values, and whatever the good matches I am getting, I have appended in this particular good matches array. Okay. Now you have to draw the matches before and after the ratio test. For this, I am using this particular function. Okay, for uh, matching, for plotting the particular images for before and after the match. Okay, here I have used this particular function. Then another function I have used. Okay, for matching all and matching the good or before and after the Lewis ratio test. I have just plotted side by side these two particular plots. Okay, and how I have plotted. See here, in matplotlib library, the particular PLT function is there. Okay, I have used this particular function. Then I have used the subplot function. Then that I have said here that what are the total raw matches and what are the matches after Lewis ratio test. And already I taught you that how to run this particular notebook. Go to runtime. Okay, you can change runtime also. You can use GPU or TPU if it is a large data set. If you would be performing this particular Lewis ratio test and you would be publishing your results, okay, in a journal, then you have to at least perform this particular analysis on a very huge data set of 10,000, 20,000, or 50,000, 1 lakh images. Then in those particular cases, you can provide the link. Okay, you can extract in your own Google Drive the data. Okay, as well as you can provide open source link also, depends on you. Then you can change the uh, hardware accelerator to GPU or TPU. Then you can save it here. Here I am just using the CPU. It is the by default available in Google Colab. Okay. Then after it is selected, I have just have to connect. Okay. It would be connect for you. It is reconnect for me because of the fact that I have ran it previously. Okay. Just prior to this session. Okay. I ran it. That is why it was showing reconnect. Now I have been allotted RAM and disk. Okay. Now I'll try to run all. Okay. Then see here, it is executing. Okay, you can see here at the bottom, it is executing. Environment it is showing as Python 3. Okay, yes. So now I think my notebook has run successfully and it is showing me these particular results. Okay, just 1 second here. Here you can see what are the KNN matches before ratio test and what are the good matches after ratio test. Okay. So before, the total raw matches were 604. In total, these all lines would be 604. Okay, these all the lines which you are seeing in different colors. Okay, they would be 604. Okay, but after your feature reduction, they have been reduced to 80. Performing the Lewis ratio test and keeping the threshold of as 0.75. Okay. So they all the good features which we can take for our analysis, for our object detection, for our feature extraction. Okay, those particular aspects have been reduced to 8. Okay. So this is regarding Lewis ratio test that you asked me in your previous session. Okay. Now I'll be just demonstrating you another thing which is safety. Okay. Just give
Sir,
me one minute. Yes, yes, yes.
in this, after the reduction, we
Hmm.
also get some error also. So how we calculate that also? Maybe.
After reduction, you are getting some error. Please elaborate your question. I am not able to understand because here I am not getting any error. Please elaborate your error.
It can be error or it's accurate all time. It's give accurate matching.
Okay, okay. You are saying that in in these 604 features, these 80 features have been reduced.
Yeah.
So these out of these 80, there might be some error. This is what you want to say.
Yeah, 80 will 100% accurate, or maybe there will be some error also get.
No, no, no. In case of your keep feature extraction, error wasn't there even in the first step also. These all the pixel values were different. Okay. So it was trying to just match. Okay. Error was not even at the first step. We are just reducing the number of key points because the larger the distinction between key point A and key point A would be there, the practical applicability would be large. Okay, that is the thing. Okay, if from this 80, definitely we would be reducing it further to three or four features. Okay, that is particularly very very essential for us. Okay, but error wasn't there even in our first step. These were distinct key points only. Okay, so need not to worry about the error, but you just try to perform this exercise yourself only. Try to change the threshold. I have made it to 0.75. You just try to increase it in a stepwise format manner and try to plot yourself. Then you will see that how many good matches you are getting. Okay. So as
Yeah.
and when you would be increasing the threshold, the number of good matches would be reduced. Okay. Or it is not error, but particularly you can say that the amount of the features which are very, very essential or beneficial for us to perform the analysis would be decreased. Okay. So
Yeah.
you try to perform this exercise, take this notebook, and then you try to see yourself, and you would be getting a but you would be much clearer after you will perform this exercise. Okay.
Okay, I understand. Thank you.
Oh, okay. Okay. Very good. Let me just move forward. Yeah. Let me just move forward with another notebook which I have prepared. Where it is? Okay. Okay. It is here. Yeah. Here also the runtime got disconnected. Sorry about that. Okay. So yeah, what is shift? What is surf? That is in brief I have written for you. Okay, you can read. Okay. Already in much greater detail I have provided you the notebook. Okay, in my previous session, but here also for because some of you must be new or some of you must be unable to understand. That is why I prepared a much simpler notebook. Okay. So here in this notebook, I want to apply those particular shift and surf concepts as well as another ORB concept, which is newer concept. All three concepts we'll just try to demonstrate. Okay. How we'll try to do that? First of all, we have to reconnect or connect to the runtime. Okay. That I just did. Then you try to see here where my cursor is going. I am installing all the requisite libraries. I am importing some of the functions. Okay, then I am defining image. Okay, I try to run this particular cell. Okay, and try to see whether it is running or not. Yes, it has run successfully. Then I am trying to upload an image. Okay, upload an image. Here I performed this particular analysis on this particular image. It was a 2D image. Okay, so I didn't get much of the results, as I already taught you or already told you in my previous session. Then in case of your 2D image, you won't be getting much of the results, which would be distinct. Okay, so let me perform this task, that I need to save an image. Okay, particularly in which area I should take, it should be autonomous driving. Okay, autonomous driving. If I search this, okay, and I take an image, leave that, any real image will work for me. Camera image, it is also not working. Any camera image, okay, camera image, okay, not like this. Any panoramic image, panoramic camera, okay, no problem, nothing like this. What should I tell? Flowers? Yeah, this particular image is very good for us to demonstrate. Okay, let me save any of this image. Okay, save image on my desktop. Okay, let me save one more image. Okay, so I won't be having any dearth of data set. Yeah, which one should I choose? This one, because it appears real. Yeah, okay. So those two particular images I just saved. Okay, then I try to demonstrate. Okay, I'll try to upload these two particular images. Okay, where these are. Yeah, fine. Okay. So I have uploaded this particular image. Okay, then applying shift. Okay, how I am applying shift here? Just try to see here. This is nothing already built function in your OpenCV library. I have just called this particular function. Then I have tried to I have tried to put the key points. Okay, then I have tried to print the number of key points which I have just detected. Okay, pre-built function, nothing much new is here. Okay, let me just do this. Then it has performed the analysis, and number of key points that has it has detected is 3765. Okay, it builds a Gaussian scale subspace, finds the key points, then assigns the orientation, and creates a 1 to 8 dimension descriptors described in the local patches. Okay, now eh, I have applied shift here. Okay, and I restricted myself to this one. Another thing, okay, which you can apply ORB, which is the newest detector. Okay, in our computer vision domain, this particular orb detector also you can apply. It has already been embedded in your CV2 library. Okay, like this, you can just try to apply it. Okay, then here also you will get the number of key points. Number of key points here is 500. In previous case, it was 3765. Okay, this one is the latest detector. Okay, this is very important, that the convergence is, I told you the complexity should be minimal. The convergence should be as soon as possible. Okay, those two particular aspects are very important. And the third aspect is time and space complexity should be minimal. Okay, so it will use the Hessian matrix. It is having a very shorter 64 dimensional. Okay, it is very in short. Okay, fast convergence is there. Okay, and fast library for approximate nearest neighbors are used here for matching. Then you can compare. Okay, in case of your augmented reality for your panorama stitching. Okay, panorama stitching is nothing but your 3D reconstruction. This is very useful. Okay, so next analysis, is, I think, related to shift only. Okay, so I'll delete these particular cells. Okay, let me just move this here. This is same only. Okay, yeah, shift only, orb only, both the things I demonstrated. Yeah, okay, I shouldn't have deleted. Okay, no particular thing is there. Okay, let me just rerun if feature. Yeah, so after this, okay, within two sets of that particular image only, I am performing feature matching. Okay, using this particular feature matching only. Sorry for that. I deleted using the surf. I prepared the code, but it just got deleted. In the notebook, I'll provide you both the feature matchings. Okay, so using the orb as well as in your surf also feature matching I'll try to provide. Okay, the Lewis ratio test after the performing the test this and using the surf. Okay, using the surf and using the orb. Okay, and first of all we have to perform the key point detection. We have to perform the analysis. After that, whatever features we have extracted, total number of features which we have extracted is 500, and after reducing those number of features using Lewis ratio test or any other ratio test, these are the results which I am getting. Okay, for orb I am getting these particular results, and for serve you will get the similar results. Okay, similar image you will be having, which I'll just try to put in a cell above to this code. Okay, so this in this form and manner, you can apply shift, you can apply surf, you can apply orb, as well as you can reduce the number of features to orb using the Lewis ratio test. Okay, and these are the pre-built functions in the Python. All the functions are pre-built, but after the class is over, please try to download these particular codes and try to explore those particular pre-built functions. Exploring those pre-built functions will only give you the idea that how these functions have been created, why they are able to perform some kind of analysis, as well as how you can define your own functions. These all the aspects you would be able to understand if and only if you would be seeing these particular codes along with the requisite functions and try to use them for a particular practical application. It may be autonomous driving, it may be related to your field of interest, but as a student of this particular subject, please try to apply those particular concepts, because then only you would be able to work on some practical project or industry scale project. Okay. And if anywhere you face any doubt or some curiosities there, feel free to ask me anytime. Okay. So this was all from my side. Okay. Thank you
Sir,
all
one
for.
thing I just
Yes, yes, yes.
checked out that what we can use for real-time basis also.
Yes,
Most
yes.
of the
Yes, yes, yes. Real in real time basis means you want to apply this particular concept on some kind of a webcam feed or a video
yeah,
feed. That thing. Okay.
that things. Yeah.
Yes, yes, yes. You can definitely do that. Okay. In here, I will just give you the hint. Okay. Here I am uploading a particular image. In case of instead of uploading an image, you can upload a video also. Okay, or you can use the CV2 function to open your webcam also. So that particular facility is there. Okay, after that you have to perform some of the manipulation within this particular code, and then you would be able to do this. But I'm not sure whether you would be able to do this in your particularly for your webcam. Okay, for video analysis you would be able to do this in Google Colab. Okay, I'm very sure of that. But for your webcam, I don't think so. Google Colab is having access to your webcam. It has been restricted as a company policy. Okay, so you can do
Yeah,
this.
Google Colab not allow webcam.
Yeah, it will won't be allowing you webcam, so you can do this particular analysis in your local computer. Okay, if you
And
want to.
also shift, also we can do in real time basis also
Yes,
shift.
yes, yes, yes. You can do this in real time basis because for autonomous driving, already these are being done in real time. Okay. Some of the things you have to just manipulate, like I am show for that you have to use video show. So some of the manipulations you have to do, but definitely you would be able to do this within real time. Okay.
Okay, sir. Thank you.
Okay. So this was it from my side. Okay. For this particular session, thank you all for joining the session. Okay, if you are having any doubt, then feel free to ask me. Otherwise, you can kindly leave. Do join the session next week, same time, same link. Okay. Thank you all for joining the session. I hope it was fruitful for you guys. Okay. And thank you all.
So
Yes,
one
yes.
question I have, but
Yes, yes.
not related that topic,
Yes, yes, yes.
another topic.
Yes.
So in video footage or in image,
Hmm.
can we calculate any person height?
Yes, yes, yes. You are definitely able to do this, but for that, you have to perform some of the calibration. Using stereogeometry, you would be able to do this, or you would be able to do that. But in real time, it is very beneficial if you perform some type of camera calibration. Okay. With the stereogeometry, you already know the steps. With your webcam feed, if you want to do that, then I can suggest you some camera calibration. Like, what shall I suggest you? You take a object of a known dimensions. Like this, I am taking my phone. Okay. Can you see my phone here?
Yeah, I can.
Yes, yes. Now I know the dimensions, okay, of this particular phone. Okay, it is of known dimension. Okay, then I'll try to bring it closer to my camera at a certain distance. I know the Z, I know the depth. Okay, try to capture one image, two image, changing the Z. Okay, then in this particular form and manner, first of all, I have to calibrate my camera, my webcam. After that calibration, it is 100% possible that if I am standing in front of the camera, it will automatically show me my height. Okay. And the limitation which in this particular project is that the error which you will get is plus minus 30 centimeters. Okay.
Okay. No, I try to implement that in CCTV basis. Like
Haha.
I show a example
Okay.
that if I capture a door height
Hmm, hmm,
like
hmm,
7 feet or 8 feet
hmm,
maybe,
hmm, hmm, hmm,
and
hmm,
7 feet height, how much pixel are available
hmm, hmm,
in an image.
hmm,
So I also capture a person height in the entry or exit time. A
hmm,
person
hmm, hmm,
photo also capture. By
hmm,
capturing photo, I can calculate the person how
hmm.
much pixel will be there. So we can divide that also by, I can also assume that much height can be a person.
Yes, yes, yes. You can do this, but that is very trivial. Okay. If you want to know it exactly, then you have to go for calibration. In an image, some object should be there always. Okay, which is of known distance. Okay, if for example, if I am standing side of a table, if you
Okay.
know the height of the table, then you would be able to know my height. That is a
Yeah.
particular constraint. Okay.
Mhm.
So you try to calibrate. That is what I am telling you. Your approach is right. I am not against of it, but the practical aspects as well as the research aspects of this particular approach are limited. That is what I am trying to say. I am not very confident of the results. That is what I am trying to tell you. Okay. But your
Okay.
approach might work. Your approach might work. You just have to see what accuracy is desired and what accuracy you are getting through this particular aspect, through this particular approach, and then yes, it might work, it might not work, but the approach which will 100% work, that I already told you, it is using camera
Okay, sir.
calibration only. Okay.
Okay. I check out also that.
Okay, okay. You can check it out.
Okay. Okay. Thank you so much, sir. Thank you.
Okay, okay. Thank you. Yes, Swati, any doubt? Anything? You are not audible, Swati. Only your camera is on.
ये महंगा पड़ेगा क्यों फोम महंगा रहता है फोम महंगा रहता है इसको भी लोग फोम बोल के बेचते हैं फोम नहीं रहता है इक्लॉन रहता है ये हार्ड रहता है और ये एकदम सॉफ्ट रहेगा यानी उसमें फोम में उसको सिर्फ थोड़ा सा रहता है इक्लॉन
Any doubts, Swati?
तो आता है 1600 फोम वाला रहेगा 3,500 इसमें थोड़ा पतला नहीं आता क्या आधा ले ये पूरा कवर डाल के देते विथ कवर 3,500 जो पिछात के अंदर में मिलती है वो कोई काम की नहीं वो पिछात वाले वो इक्लॉन के रहते
Okay. If no doubt is there, then thank you all for joining the session. I am ending the session for you all guys. Okay. Do join the session next week, same time. Okay. Same link. Okay. Thank you. Thank you all for joining this session. Bye. Have a great day.